Lots of energy this morning. We took extra melatonin.
Coming in hot.
We're really ready to go. I don't know about you all. We've got an awesome guest with us today. So we've got Shane Ronan. Shane comes from, decade plus in service provider. Actually, I don't know how long, Shane. I assume you're not quite as old as some of us, but you're older than Dave, so you're at least. So yeah, Shane, tell us a little bit about yourself, where you come from, and
Sure. So currently working at Red Hat in telco solutions team as an architect. Prior to that, I was with Verizon for about 7 years, working in the wireless network solutions team, basically figuring out ways to build out the wireless network, automation, mostly planning. Prior to that, most of my experience is on Wall Street and high frequency trading and ISP background, running internet service providers. And people say, how does the high frequency trading world translate to the ISP business into telco? And what I always tell people is it's all the same, right? It's all about connectivity. It's all about understanding the traffic flows and how to speed them up and what the tolerances are. So my background for the last probably almost 25 years has been how to automate and streamline networks of different types.
Awesome. I love it. Cool. So, Shane, 20 years ago when I was, starting to architect enterprise networks, I remember thinking to myself, wow, how do I, I need to figure out safe ways to architect networks. And so, by doing safe ways, it's like, okay, what are the biggest networks on the planet? And that's always service provider networks. Problem I always ran into is service providers won't tell you what they're doing. So it's
or how they
super
did it.
Black box central. It's competitive advantage for their company. So I'd love to start kind of at the base of the stack, and then I'm going to shut up and let everybody else jump in. So let's say today I have remote sites. How are service providers building out to remote sites? And then, obviously they're selling those services, but, I'd kind of love to hear how, the masters of connecting remote sites together, and we call those edge and far edge now, but they're just remote sites.
Sure. I think the biggest thing is fiber in the ground. So if you go back 20 years, there was a huge push to put fiber in the ground, and we all thought there was tons of fiber that was going to be available, right? All these CLECs went bankrupt. All these long-haul providers were putting fiber in the ground. But as it turns out, it never went to the right place. So there's a big push by the service providers now to get more fiber in the ground, more density, and to get it to go to the right places. So, whereas before you had central offices and everything was kind of brought back to central locations, data centers, now the network is much more distributed. So service providers are, spending their time trying to figure out, like Verizon, for example, committed $9 billion about 4 years ago to do a project to basically connect every one of their sites with their own fiber. And that's all their cell sites, all their central offices, and basically build a giant mesh. And so they went into the top 50 cities. I was talking about, going back 20 years, telcos were putting a lot of fiber in the ground, and it was much more point-to-point, right? You were connecting major cities, major telco hotels. But there
was driven by a different business, too, not wireless.
Exactly. Right. Now, the push is to get wireless out to the edge. So part of Verizon's build was not just to go to cell sites, right? So traditionally, and this surprises people, 3 years ago when I was at Verizon, 70% of their cell sites had 300 megabits or less of backhaul.
Or less, yeah.
So 300 megabits is not a whole heck of a lot when you're considering, that people are getting 10 megabits down to their, or a gig down to their phone now, right? So as the move to 5G was coming, they needed to figure out a way to densify the edge with fiber. So they spent this $9 billion and they partnered with Corning to put fiber in the ground. And that turned out to be actually a huge problem in and of itself, because when you're in these 50 NFL cities putting fiber in the ground, you've got different contractors working in every city. And so that became a problem
Yeah.
of how do you get the maps back from all these providers of all the fiber they're putting into the ground to get them into one system, right? So geospatial becomes a problem. And things that, even the carriers who've got huge amounts of experience at this didn't think through properly, right?
Yeah.
So especially, Verizon was rolling out millimeter wave, right? And so millimeter wave is, down to the, light post on your street. And so to answer your question about how service providers are thinking of distribution to the last mile, right, to that far edge, to a small business or a medium-sized business, they're looking at densifying the fiber out to those edges, right? So if I build this backbone and I'm going down every major street because I'm putting in light posts with cell towers on them, I can branch off to do a business, right? I can install fiber into a business. And so Verizon, that meant actually rolling GPON out all the way to businesses and to cell sites.
Which they already had with Fios, by the way. So it was not a new thing. Yeah.
Right. For them, it was GPON. They didn't do DWDM all the way out to the edge. They decided to go with GPON because it was a technology that they already had in-house, right? And so they already do some DWDM, CWDM, solutions. But if I'm building out a product, right, where I can deploy solutions out to the edge, I'm gonna base it on something that I know that's reliable, right?
Well, there's like the thing you just brought up. This is the problem we had at BT, actually. The same problem many years ago when I was there. The map of where the paths, like fiber diversity is an important thing, especially for a wireless network, not even a broadband network, but like you have 911, et cetera, requirements. The tower goes away, it goes away, and that's a problem, right?
Right. And so, the others, I think the solution that carriers these days are doing to the tower going away problem is overlapping coverage.
Yep.
So they've gotten away from worrying about each cell site being redundant, which is actually a pretty smart architectural pattern, if you ask me, right? Is to get away from worrying about the edge being redundant and just have such overlapping coverage that it doesn't matter, right? That if a cell site goes out, you may have, throughputs may go down, but everybody's still got coverage. And really, at the end of the day, the only thing they care about is 911 calls, as Tom mentioned.
But back to what you're saying, like if the fiber diversity in the city isn't set up right, that still doesn't work either.
Right. Then you get into issues of whole rings going down and every site in an area going offline, which does happen.
Surprise. Yeah.
Yeah,
So
it's interesting. So it's kind of it's a pets versus cattle. So instead of cool.
Yeah, it goes back to the same patterns that we've seen, with OpenStack and OpenShift, right, and cloud patterns of don't baby your servers, don't baby your cell sites, build lots of them.
Failure. Yeah.
And build the failure into it because while they might not be Amazon and they may not be running the Chaos Monkey, life is chaos, right? So you have to assume that if it can happen in the network, it will, right? That cell site that's on a telephone pole on the edge of the street is going to get hit by a car, or there's going to be a power outage at those poles.
Yep.
Back to your original question.
Crazy British people stripping copper off the lines or setting them on fire. I think that was the thing.
Setting them on fire, yeah.
That's what we're doing for a while.
Because 5G causes, 5G is the government's way of controlling you.
Heard it there, but straight from the source.
I've got the shot and the microchip inside me. But go back to your question about an enterprise. I think the traditional way that enterprises would have done that 20 years ago was either, frame relay or as we moved into more modern days, MPLS.
And all leased too, not
all
owned,
leased.
Nothing owned, right? Like you're saying.
And as we moved into, the last 10 years, we started going to hybrid VPN solutions and things like that, where businesses were able to put even mission critical traffic over the internet as things have gotten better. But the goal for the providers is to push that all to wireless. So if I'm a business and I need a gigabit internet connection, there's no reason the same infrastructure that's pushing fiber out to my 5G pole outside their office with millimeter wave can't, one, give them millimeter wave at a gig, right? And
Yep.
I've been involved in testing where we've tested millimeter wave up to 4 gigs of throughput on a single CPE or a single UE. But the option there is also, since I have the fiber route outside the door to feed that cell phone tower, that I can also provide, a GPON 1 gig internet.
That's the thing that's been curious. Remember that AT&T came out with an option for basically what you're describing, where they were doing power, and then they had Wi-Fi or 5G type Wi-Fi pointing at the houses. And I always thought exactly what you just said, like, well, you're already there. Why don't you just run a fiber to their house?
Usually it's because running that fiber, that lateral fiber from the middle of the street to their house costs a lot of money. So if I have to build a fiber into a house, and that's why Verizon, AT&T, all of these guys have gone away from fiber to the home.
Yep.
Because it costs $1,000 to run a lateral, which is what they call the fiber that runs from the street into the building. And so I'm a single family home. I can only serve that single family off of that one lateral. Yep. So now I've got before I even put any electronics on that, I've got $1,000 invested in bringing that customer online.
Yeah, and
it takes
it's
a long
tricky
time
even
to
in higher
recoup
density
$1,000.
areas.
Yeah.
Like you're saying, it's actually, like even in a dense area, when you're running to an apartment building, like, where Dave is in the UK, where all the houses are stacked together, even that's still like you connect, a whole street, and that's still not necessarily going to work out.
Right.
Yeah, or you can live in rural America and not get fiber at all. And never
That's the opposite, right?
Because there is no business case and there is no 30-year ROI for service
just
providers.
Brent, you just have to wait. You got to wait a little bit longer until Google comes out there so they can monetize all your traffic for you when they offer it. Because Shane, that's the other thing that's going on here, right? I mean, the telcos are now competing with Google as an example, and Google's like,
Google
I'll
Fiber.
spend the $1,000 because I'm going to monetize the crap out of everything that comes across that.
Yep.
Do you think the telcos are moving in
multiple revenue streams
of doing that too?
I think telcos have tried. I think you saw that maybe 5 years ago. AT&T bought Time Warner, Verizon bought Yahoo, and they started Verizon Media. And what you've seen is that they don't know how to be in those business spaces.
Right.
Yeah, that's all the
but no
metadata
different than-
scraping that was going on, and that like all malfunctioned. And part of it too is regulatory, right? The telcos are regulated differently than Google is.
Yeah.
Right.
But that's no different than Google trying to do Google Fiber, right? And essentially finding out that they're not in the operations business of operating a consumer network, right?
Either. Yeah.
That's right.
Yep.
And so they've exited that business. So I think everybody's tried to get that multi revenue streams per user. But yes, there's still a ton of monetization that goes on by other ways, by bringing having Netflix pay to put caching engines in your edge data centers, right? Mm-hmm. So that you can get more revenue out of a single customer and you don't have to backhaul the traffic. But my point was, if I'm spending $1,000 to run that lateral at $50 a month for internet,
take a while to make that back.
With no contract now, because every provider's had to go to no contract for their internet, it takes a long time to make that back, right?
Yep.
Yeah.
And that's without any electronics, and that's without a single truck roll. So if I can stand up a 5G node outside an office building or on a street with multiple houses, I can now serve the same speeds to multiple houses off of one fiber drop, right?
Right, off of one truck roll, basically.
Right, and I'm going to push everybody to do self-service install.
Yep.
So that I don't have the cost of.
Well, that's what we're doing today. I just saw a commercial yesterday about Verizon's basically self-serve install. We'll send you this box. You plug it in. It'll auto provision. Off you go.
Right.
Yep.
But Brent, hopefully sooner than later you'll have options for wireless high-speed internet, because besides millimeter wave, now with the C-band, which is the mid-range sub-6 frequencies being rolled out, they're, at least Verizon and a couple other providers are starting to offer 500 meg internet wirelessly. So that's their whole push, whether it's a consumer or a business, it's to get the density per node, right? If I can get a higher density per node, especially a mix of businesses and consumers, I'm in a really good place, because, up until COVID, which is a whole nother conversation about what that did to networks, but up until COVID, internet providers, people like Verizon service providers, were in a great space if they had a mix of enterprise and residential customers, because residential customers use their bandwidth at night and businesses used it during the day.
During the day, yeah.
Now with work from home, that's been a little thrown off, but eventually we'll get back to that equilibrium. And so the goal for a carrier is to push that speed out to the edge wireless delivery and bring businesses on there. So as an enterprise business, I'm no longer looking for two fiber providers. Maybe I get one traditional terrestrial internet link, and then I use a 5G backup, right? As opposed to back, 10 years ago, you were looking for two different internet providers or two different frame relay providers or two different diverse paths, right? I think the move is much more to one terrestrial path and one, RF path.
Well, the wireless too makes it more, business-wise possible for multiple providers to come into the space and compete. That's the other thing. I mean, like you're saying, like the capital expenditure to come in and drag fiber and whatever has been prohibitive to a lot of challengers in the markets. I mean, where I am right now, I have two options, but only recently a second option. It was pretty much just cable. That's all you could use. And now the incumbent has been rebooted and is redoing fiber to the home now. So now there's a second option, and they're challenging the price, and all the the good market things are happening again. But there are a lot of places where like where Brent lives. How many options do you have? One?
Yeah, it's DSL. There are no
maybe
CLECs.
a half of an option.
There's that strangleholds the market, and that's it.
Right.
So let's move up the stack a little bit.
Sure.
So we've kind of covered outside plant, layer 1. What are you seeing in layer 2 and 3?
So, I want to say that we're going forwards in reverse. And what I mean by that is, a lot of the complexity is being pushed out of the layer 2 and 3 space. So, big iron is no longer necessary to do a lot of the things that, we used to have, the big switches, that would take a whole rack in a central office in order to switch, a terabit. We no longer need the big iron. So, you're seeing is that you're pushing the intelligence and the routing to the edge. So, even 5 years ago, a lot of the transport back from a cell site was layer 2. And your layer 3 switching happened in your switch sites, right? Because I needed to carry diverse kinds of traffic to the edge. I still had 2G, which had layer 2 requirements. And so over time, you saw that to being layer 2 encapsulated over layer 3. But now we're going to layer 3 just straight at the edge because silicon has gotten so cheap, and merchant silicon has gotten really cheap. So you no longer need to buy your equipment from, Cisco or Nokia. You can go to, a competitive carrier like Arista and get with, a cell site router, or CSR as they call it. And those cell site routers now are doing everything. They're doing your DHCP if you're doing DHCP at the edge. They're doing all your routing. They're doing all your classification. Because as we're moving away from traditional basebands or traditional hardware for the wireless network, which was vendor silicon, it was purpose built, and we're going to commodity hardware. Some of those capabilities don't exist in software that existed, like the marking and being able to push intelligence all the way down to the server. The one area where I think we are moving forward is, I can tell you, for example, Verizon is moving to segment routing, right? So they're moving, but again, that's about moving the intelligence out to the edge, right? It's about moving your routing intelligence. Instead of having all your routing intelligence being in a central location, it's about each router knowing what it needs to know to do its job. And so while, like I said, maybe I'm speaking from two sides that I say it's getting simpler because we're moving everything out to the edge. That allows you to enable different features like network slicing, right? Because I have now intelligence out at the edge to do all my classifications. I can have more queues. I can break down traffic farther and segment it farther.
Pre-processing activities that are happening too. And,
exactly.
And all
right.
That.
I can deduplicate traffic at the edge because I'm now going to have servers out there, so I can cache more directly at the far edge. So that impacts the layer 2 and layer 3 also.
But then the flip side of that is that now we're moving more computing out to the edge. This kind of gets into the MEC, 5G edge thing, and Kubernetes, et cetera, right? That whole thing.
And that complicates not just, from where you guys would think or people would think of like, okay, now I have, I've got more compute nodes. And if you consider the fact that the largest carrier in the U.S., Verizon, has 2,000 field techs that cover the entire country, and they're all RF engineers.
Yeah, what are they going to do if the server breaks on the edge?
Right. And they might not,
the PCEP server at the edge goes down. What do they do?
Right. And they may only visit that site once a year, and they may not be able to visit some of the cell sites for 6 months at a time because of snow, or they have to take a snowmobile there, or they have to take a helicopter to get to the cell site. So, when you're looking at the service provider architecture, specifically in wireless, you have to consider all of these kind of corner cases, which are more the rule than they are really the corner case.
It's not what it looks like on the slides. These are, there's a friend of mine who's in Montana actually, and he works for the DOT there, but they do telecommunications stuff for the DOT, and just what you described, last week he was on the top of a 5,000 foot mountain where there's fiber run on a pole individually all the way up the side of this mountain to the tower at the top, and one little fiber, and that one of those poles breaks as an avalanche or who knows what, it's over, and that site's down for a while.
Well, that was also one thing I didn't mention when we were talking about transit or transport, is that most of the sites have fiber, but there's still a decent amount of cell sites that are served by microwave.
Microwave, yep. Yeah,
from a kind of a hub and spoke model, because it's in a hilly area where putting fiber in is not, feasible, and all these things play into when you're looking at your architecture, and as you're moving into the next generation of wireless, right? Talking about virtualization at the edge and more services to the edge. Well, how does that play out for sites that can only ever have a 200 megabit link to them because they're on microwave, and there's no way to get fiber to them, and quite frankly, there's no business model to bring fiber to them
as well, right? But like in the case I described, I mean, they basically had to go chisel out up the side of this mountain, basically a conduit path, and then they realized this is crazy. This is going to, this is taking me, this is going to take me a year to do this. So they put poles in and dangled the fiber on the poles. But, and back, what you were saying too, like the current strategy now is to overlap coverage. And no overlapping out there.
Right.
What are you going to overlap with,
So you mentioned segment routing, so that's interesting. So is that getting away from, traditional RSVP, EE, and kind of moving it? It feels like there's a lot of disaggregation also happening out to the edge.
Absolutely.
So.
Yeah.
In a previous mobile architecture, there was a lot of, they used tunnels, basically. That's what Shane was saying. Rather than native IP, they were running VPLS in a lot of instances, right? And that's
because they had to for 2G required, and even some things in 3G require that centralized, adjacency, right? So it has to look like it's adjacent, even though it's not, right? No. But Brent, to your point, absolutely disaggregation, right? As we're disaggregating the basebands into multiple components, and in 5G you've got this concept of the DU that sits at the edge, the distributed unit, and the centralized unit. The traditional transport networks for cell phone, or LTE, were all hub and spoke, right? Everything came back to a central location. Well, as I'm building these more organic networks that are going down to the edge, I don't want to be stuck with this hub and spoke model, because it's not necessarily the most efficient, right? And doesn't provide for me being able to just, okay, this customer that I'm serving on this 5G requires redundancy. So now I just swap another link in that connects two rings or two, metro areas together.
It's kind of a weird overlay. It was kind of a weird overlay architecture that they had,
Well, they essentially moved their T1 architecture, which fed the 1G and 2G networks up through, and then as they got into 3G, they got away from the T1s. You used to have, for every phone call, you had a channel on a T1. So for every T1 you had out to your cell phone site, you had 24
channels,
24 phone calls. But as we moved into the data world, we now needed a way to make that hybrid. So they slowly moved away, but they didn't change the way they were building the networks, right? They were still this point-to-point kind of.
Well, that's funny too, because remember, has everybody forgotten about voice over LTE? It's basically a mimicking of that same pattern, right? Like, we need a dedicated channel, even though it's a virtualized path over all of this stuff. back to the home office, right?
So yeah, it's definitely about removing the need for central sites, right? A lot of the traditional ways that, really up through 3G, you had traditional banks of racks full of equipment that ran your cell sites, right? So you had a baseband at the cell phone site, you had a central processing unit with this giant cabinet that had channel cards and all these things. And so everything had to physically be point to point because you had to physically connect. Those things had to look like they were adjacent.
Yep.
But as you moved into 4G, you didn't need that anymore, right? Everything became IP based, but you still had 3G operating, so you couldn't move away from that model because 3G was still operating. Well, as we're rolling out 5G, they're also shutting down 3G.
Yep.
So now they can go into a much more disaggregated, more organic model for the network, right? It really becomes a traditional IP network, but your routing intelligence is no longer just a big iron in a data center. It's
but back to the pros and cons, right?
Exactly.
Like we were talking about earlier. I mean, the challenge now is the organic part of the thing, and then being over prescriptive about that.
Right.
We were talking about.
Well, also how to operate it and manage it, right? You've got people who've worked for these companies for a very long time who've
now don't
been
know
very
how to
accustomed
run.
to doing things one way, and now you're telling them that that's no longer the way. So how do we reskill and retool all of our orchestration tools and and
which
as we move
gets
up
into the further challenge of now we're running servers and software, and I mean this is so far from RF and cable cable patching and everything that this is a new challenge for these guys, for the operators, and like you're saying, the actual
and it's happening all at once, right? We're changing the way the networks look at layer 1, layer 2, layer 3, all the way up the stack all at once.
All at once. Yep.
So you're changing the whole way the far edge operates your cell sites. You're changing the routing. You're changing now you've got a multi-tiered hardware where you've got COTS hardware, maybe a third-party network overlay, and then software from a traditional NEP, a traditional provider providing containers to run on that.
Yep.
And
but that's a huge challenge. No, go ahead, sorry, Brent.
Oh no, just so we're diving into L4 here pretty quickly. So one thing. So traditionally, L4 segmentation. Well, let me just say network segmentation in general to get security zones out to an edge site was typically VRFs. You've got some kind of encapsulation to carry that through. Whether that's like whatever. Whether it's BGP, whether whatever your control plane for your MPLS NCAP is going out to there. I assume that VRFs are still at the edge, but also I'm guessing there is some interest in kind of a zero trust model where you're saying
absolutely.
I no longer need to segment. I no longer need to kind of mirror the VLANs of circa 2000, where every security zone has a VLAN. We scaled that out with VRFs, but now we're getting into a place where are you even really trusted within that VRF? So I'm kind of curious.
Absolutely. Things like network slicing kind of play into that, where you're basically you're guaranteeing that VRF all the way down to the user's UE. And the way that that's being solved is that's where the intelligence is moving. So you're no longer worrying about the transport segmenting the traffic. You're actually segmenting the traffic higher up the stack, right? So the actual cell phone network is going to encrypt and isolate that traffic all the way from the UE all the way into the network. And I'm going to guarantee for those flows, I'm going to guarantee, depending on the economics or the way that the contract is written, I'm going to guarantee a certain profile for that traffic. So it's now no longer just isolation, it's latency, it's packet loss. I can actually now, at an application level, guarantee all that. But again, that's happening in software, right? That's happening all the way out to the edge. So even within a far edge site, we're moving intelligence closer to the
literally
edge.
Every 5G deployment I've worked on, including the ones with you, have done it literally that. Like the servers that are being implemented have VLANs off the back. Their NICs are connected to different VLANs, and there's a bunch of them. It's not like one or two, just so people understand how this works. I mean, there's a dozen VLANs at some places. Some operators are using off the back of every server in a rack. It's no longer, like you were saying, like aggregated down the street. As
we've evolved from even that, right? Because that's still sort of the model, right? But as we move into more orchestrated edges, I can do network slicing where I can guarantee a profile and a guarantee security for traffic all the way down to the UE, the user equipment, to the cell phone, because that UE is participating in an admission control protocol, right?
Yeah.
So, we take that for granted, right? That you pick up your cell phone and it works, but there's a whole conversation going on behind it with, is that cell phone allowed on this network?
Or which network? That's
right.
The other thing. There's multiple, there's multiple customer VLANs even for the UEs.
Right. So now that we're getting, now we get into network slicing. There are now slices. They don't call them VLANs anymore. Now we're calling them slices. So I register a phone to a slice or a UE because we no longer talk about just phones, right? Because as we move into 5G and
it's a transmitter.
Buzzwords like Industry 4.0, right? Everything is a UE, a user equipment. So that could be a home router. It could be a street light. It could be a car.
Something with a radio in it, basically.
Right.
Yeah.
Part of the admission control protocol allows the service provider to set parameters all the way down to the UE and then gets enforced all the way down to the UE. So it gets enforced not only on the L3, L2 network back from the cell site, but it gets enforced on the RF side as well. So that's where we're going. The challenge there is really all in orchestration to make that dynamic, because I don't want to have to pre-provision all these slices to every cell site. We're talking about,
imagine, so frame this up for people that are listening, how messy this actually is in a network today, right?
Yeah, so, you consider a network like Verizon's that has 100,000 sites across the country. And I'll just take any major corporation. So we'll take that has a lot of fleet. So we'll take Coca-Cola as an example, right?
Yep.
They've got a lot of trucks, but they're across the country. So Coca-Cola comes in and says, I want to be able to reach all my trucks all the time with this much bandwidth so that I can push out orders or I can track them, as an example. And I don't want anybody else to see that traffic because they would know where all of my trucks are, and that's maybe intellectual property or security risk or any, flip that with armored cars instead of soda trucks.
Something more valuable than soda, yeah.
Right. You can imagine the security risk and people knowing where all these vehicles are all the time.
Well, you have shipping companies that have trucks that do this, right?
UPS, FedEx.
UPS, et cetera. Yeah. Yep, same thing.
So, traditionally, if I wanted to isolate that traffic, right, I'd have a VRF for that traffic or a VLAN, depending on when in time I was. But that was static, which meant I had to know what cell site those users are going to be on, or I had to deploy that configuration to every cell site. Mm-hmm. Well, that doesn't scale, right? Because I have 10,000 customers, and I only have so many queues on my routers, and it gets, starts to get complicated.
Well, it's worse than that too, right? Because the core is orchestrated. The cores are orchestrated with different orchestration systems today too. Because of legacy and and all of that evolution, and this stuff is hanging around on the edges, and then mapping that all the way through from left to right across that network.
Right, and it's mapping it with the admission control systems, right? So that when a UE enters a cell site, right, when a UE enters a cell site, I'm not just admitting that UE onto the right wireless profile, but I'm now automatically configuring the transport all the way back. I'm automatically configuring everything in the path.
With all of those parameters in that profile, and that's the tricky part, because back to how we used to do it, where we tunnel everything around and all that, it's very hard to do that. Because everything
and at the speed, right? Because imagine a truck driving down the highway handing off between two sites. That handoff has to happen in something like 2 seconds, right? Or else the call drops. So that means that dynamic build out of that profile probably needs to happen when I orchestrate it on one site, because I see the UE come into one site. I probably need to figure out where all the neighbors are of that site and pre-provision it there.
And that's the challenge.
Constantly do that as the truck's moving.
So it's sitting there waiting for the truck to roll by, and then it's ready. I mean, this is the whole challenge I have with the whole slicing thing, personally.
So these are the challenges, but this goes further, again, Brent, as we move up the stack, right? As we move into, we spent most of our time here talking about the edge up to layer 4, and then again I'm getting up to layer 7 because all these things kind of roll together. And if you're maybe following what I'm saying is that the traditional separation of the layers, the traditional model, we're the boundaries are starting to get much fuzzier as they have over the last years. You can no longer buy a layer 2 switch, right? Every layer 2 switch you buy is also a router, right? And if you want to do layer 2, you have to freaking emulate layer 2 because there's no money in layer 2 switches. But you're seeing that across the board, right? The boundaries of what's layer 2 through 7 are where we would traditionally implement things is getting fuzzy, right?
Yeah.
And as we move up or into the network, right, from the edge where we spend most of our time talking about, into the cores, right? Because in 5G they decided to complicate things by calling it a 5G core when we've called the network the core for the longest time,
forever,
right? So in 4G it was a core, but it was called the EPC, right? Evolved Packet Core.
Yeah.
Nobody ever called it a core; it was just the EPC.
We stopped evolving after 4G, right? But
so these same things that we're talking about going on at the edge are happening inside also, right? So when 3GPP started looking at 5G specifications, because their goal is interop, because their goal is to have a single standard, they started specifying things like things have to be deployed as containers. And all traffic inside the network has to be encrypted. So everything has to use SSL, which posed all sorts of problems for the intelligence collection that we were discussing earlier, right?
Not just that, the scalability of the whole thing. I mean, getting those back to those servers, as we know, doing full-on SSL for everything is not free. You need NICs that can handle it.
You're destroying bandwidth at the same times as you're
right. Yeah.
Well, and so just to tie off, so I really feel like the traditional PE node is getting collapsed into the edge.
Yes,
and
absolutely.
That gives you kind of the dynamicity of provisioning out where it used to be, well, before I could have my MPLS VRFs getting dumped into each of my PEs, I had to define those VRFs. Well, now we're saying those VRFs are always going to be there. That's just table stakes of joining this, joining.
Right, and you're going to reduce the number of VRFs you had. Right, you're going to have your transport VRF, and you're going to have I would say you'd be down to like a transport VRF and a management VRF. And then all of the intelligence for slicing up that transport VRF is going to happen in application layer, essentially, because it's no longer the job of the network to keep that separation, right?
But that's the challenge too, right? In the implementation is saying, back to the evolve part of the packet core, it doesn't evolve overnight. And so you have, you have non-segment routing set up, but for example, you know what I'm saying? Like the way I look at this is like, it's a transitional mapping problem. You don't just turn the switch one day and everything works. So that's another evolution that has to be handled in this too.
Oh, it's a massive change. I mean,
and we've seen that.
The intelligence was always the PE node on some kind of L3 switch on the edge.
Yeah.
Now we're saying, like Shane just said, you're going to have two VRFs. That's crazy because you're going from, hundreds of VRFs to now down, thousands of VRFs down to, a transport,
and a lot of VLANs under that, map it all together,
So getting that mapped into a server itself, I mean, that's a pretty monumental change because now, so all your policy is now, you're just the security the security aspect of it alone is, well, what happens if that node gets compromised? I've now compromised all of my VRFs. So somebody now has the keys to all of these segments of the network, right?
But sort of, but since the intelligence to access that part of the network is kept in the UE essentially because it's in mission control, if somebody accesses my site and physically gets access to the network, all they're getting access to is encrypted traffic running over a layer 3 VRF, like a layer 3 link, right? They're not looking at my actual traffic, so they can see what I have there, right? They can see what my configuration is.
That's an important difference too in 5G versus previous, right? Because and this is a thing that was discussed when the standards were being formed, was exactly that case. Like you could walk into an eNode B, plug in, and start the party, right?
Right. So I mean, that's not to say that there aren't ways to get a man in the middle and all those things that you can do, but 5G was definitely built with that security in mind and keeping it out of the network and building it into the specification, right? And that's we can get into a whole conversation about how these specifications are created, and how they're created sometimes in a vacuum where the wireless guys aren't really looking at what's going on the network side,
and
the
vice
traditional
versa.
network side, and vice versa, right? So sometimes they're at odds for a Cisco is piling new features into their routers to be able to be to do a lot of this intelligence, and the NEPs, the traditional equipment providers for wireless, your Ericssons, your Nokias, your Samsungs, your Altia Stars, are saying no, we need to have that in our our side because that's part of the 3GPP spec, right?
Yep.
So again, essentially, in order to get to this vision, and a lot of what we're describing is vision, right? Network slicing is not rolled out anywhere yet, or dynamic network slicing is not rolled out anywhere yet because it's essentially not possible yet, because the orchestration of the edge and the real-time dynamic nature of these sites, partially because we're still in the half-pregnant phase.
I mean, you still have to do it ahead of time to make it work right, and even then.
But the goal is to get there, right? And that's as we move inside to the EPC and the 5G core, that's why you see all these carriers doing something called non-standalone. So non-standalone basically means you're taking a 4G network and layering some 5G features on top of it. So the signaling for the UE still happens all over the 4G network, and then the 4G network tells the phone or the UE, hey, there's 5G available to you. And that's basically because the evolution hasn't happened, or the move hasn't been completed from a 5G core, from an EPC to a 5G core. Because a 5G core is actually capable of running a 4G network. But
right, that's the transitional part.
Yeah, so today we're running a 4G network with 5G services, and the long-term goal is to get to running a 5G network that also supports 4G.
Yep.
And so things like network slicing and the dynamic nature and true orchestration will come largely with that flip. But also, frankly, a lot of work needs to be done on orchestration, which has been the problem was the problem for OpenStack.
The whole time. Yeah.
It's been a problem for a long time. Orchestration is a really hard nut to crack.
Yep.
And that's what we're gonna drag you back for a part 2 on. So we've worked our way kind of through the network pieces, and now we're hitting the Wild West of where do we go from here now that we have a bunch of servers on the edge. So Shane, this was awesome as always. We love your storytelling here on the net. So thank you so much, and we'll be having Shane back on soon to kind of cover the next step of the evolution here. Thanks again to Nexus T1, our sponsor, to pay for our website. So appreciate it. And Shane, this was great. Guys, thanks everybody for listening. Guys and gals out there, be safe. Peace and love. See ya.
Cheers.